Okay, again, guys, you're going to get your identities on the quiz. You are going to have to verify 3, simplify 4. Always look to see if you can go to a Pythagorean identity where there's a trig function plus or minus 1 somewhere. Try to look to see if you can simplify it as sine and cosines. If you have different denominators, try and get the same denominator. Just always try to do something. Now, the first 2 I just did with you, J period, and I forgot to record. So I will put it at the end of the video when we're done. But looking at number 17, all right, which side looks more difficult? The left-hand side or the right-hand side? The left-hand side, correct? So let's try and break that down a little bit. All right, let's do the best that we can on breaking this down. You want to have your trig functions next to you so you can kind of go from here and there. Now, again, you may not do the same thing I do, and that's okay. That is okay. The first thing you might do here is get a common denominator. I understand that, but we're probably going to have to turn secant into what? What's secant go with?
1 over cosine.
1 over cosine. Good. You're probably going to have to turn cotangent into what? 1 over tangent or cosine over sine. So let's just go ahead and do that now. Let's change secant theta to, what'd you tell me? 1 over cosine theta. Okay. And then I'm just going to leave cosine. That doesn't just automatically cancel out. You can't just cross stuff out. Just wait a second. Minus, I'm going to write tangent theta into what? Cosine over sine. You guys agree with that? Did everybody see that?
Yeah.
All right, I got my minus.
Can we simplify tangent?
You can simplify. You can if you wanted to. You want to change tangent to what? To sine over cosine? Yeah? Okay, that's fine. Go ahead. You can do that. Now, you can simplify each of these fractions. If you guys had like 6 over 4, you would simplify before you add it or whatever, right? Start again. So let's just... All right, this is cosine over 1, right? So when we keep change flip, we have 1 over cosine theta times keep change flip. What does this become? 1 over cosine theta, right? Then over here I have minus sine theta over cosine theta times what? Sine theta over cosine theta. Ay, ay, ay. So on the left-hand side, guys, I wrote a minus and I meant multiply. What is 1 over cosine times 1 over cosine? 1 over cosine squared theta, right? Agreed? So over here, what's sine times sine? Sine squared theta over cosine times cosine is cosine squared theta, correct? All righty, we're in business now. Do I have the same denominator? Yep. So my denominator is cosine squared theta, right? What's the numerator? No. 1 minus sine squared theta. Have we seen that 1 minus sine squared theta somewhere? 1 minus sine squared theta is the same as what? Cosine squared theta. Think about that. The Pythagorean identity is sine squared plus cosine squared equals 1, right? If I move sine over, this becomes cosine squared equals 1 minus sine squared, correct? Which is what we have here. Guys, what's cosine squared divided by cosine squared? 1. So 1 equals 1. What I want you guys to understand and what I want you guys to know, what I want you to see, is when you are verifying, whatever is in your answer should be one of the things you started with. You can convert different sides to different things. You can go a different route, but one of your answers, or your answer should, at the bottom, it should say one of the sides that you started with equals the same thing. Don't convert everything all over the place. All right, let's look at 18. 18 looks crazy, crazy intimidating, doesn't it? Okay, I get that. There's a lot going on in this problem. A lot going on in this problem. So I'm not going to tell you what side you should start with. You guys, some of you are going to start with one, some of you are going to start with the other. Personally, I think the left-hand side looks a little more difficult. I think it looks like there's a lot more going on here. I have two it's two binomials, correct? Being multiplied together. Before you guys just start going and multiplying sine times tangent and all that stuff, let's try to get everything to be similar or in the same terms. Try to be in the same terms. Sine and cosine, that's our most basic, right? So just leave it. Just leave sine plus cosine. Just leave it alone for a second. Now, how can I change tangent and cotangent? What is that going to become? Sine over what? Cosine plus cosine over sine. You guys see that? Okay, that's all. All I did was just change it to equivalent identities. Now, what do you think I should do from here? Should I do anything with my sine and my cosine on the left-hand side yet? Should I multiply them together with anything, or should I just leave it alone for a second? Let's just leave it alone for a second. All right, I'm just going to leave it alone for a second. Right now, I have two fractions that have different denominators. How do you get a common denominator when you have two different denominators? You multiply them, right? So if I multiply these together, I get cosine theta times sine theta. And then when I get a common denominator, this one has cosine, I need to multiply it by the sine, right? What you do to the bottom, you do to the top. So sine times sine is sine squared. Then here I have a sine, so I need to multiply by cosine. Well, cosine times cosine is cosine squared theta. What can I cancel out? I cannot. I see what you're saying. By factoring out. It's not that I have two of those, but what did I just create here on the top, guys?
Identity.
Yep, an identity. What is sine squared plus cosine squared? It equals 1. So I'm going to leave my little, whoops. I'm going to leave my sine theta cosine on top. And I'm going to rewrite this as 1 over, right? Cosine theta times sine theta. Agreed? Okay, good. Very good. All right, well, now what? I have two fractions that I'm multiplying together, right? Can I just cross off the sines and the cosines? Why not? You're right, but why not? Because one is adding and one is multiplying. So I'm just going to rewrite it. I'm multiplying them together. All right, so now we're looking at it. We're like, what could I do here to try and simplify this a little bit? Think algebraically. Think.
Can you divide the... split it?
We can split it. Perfect. Perfect. Can we split this up? Can I rewrite this as sine of theta over cosine theta times sine theta? Can I do that? Yeah. And then I could say plus, this becomes cosine theta over what? Cosine theta times sine theta. Because where are we trying to get to? Use this as a guide. We're trying to get to secant and plus cosecant. Well, what is secant the reciprocal of? Okay, so secant, cosine are together. What's cosecant the same as? Okay, so let's see if we've made any progress here. What cancels out in this fraction? So I'm left with 1 over what? What cancels out in this fraction? Cosine, so I'm left with what? 1 over sine. Now this doesn't look exactly the same, but it looks pretty darn close. What's cosine, 1 over cosine the same as? Secant theta, right? Plus, what's 1 over sine? Cosecant theta. Is that what we started off with? Yes. Yes or no? Okay. You can use the other side as a guide. This is the answer right here. This is the meat. That is the hardest problem I think that you guys will see. There's a bunch of different ways to get to this answer. I know some of you looked at it differently, and that's okay. But all of the verifying ones that we give you, I promise, will work out. So you just keep trying. If you get stuck on something, you keep trying. You work back and you say, wait a second, I can get this, I can do this. You guys want a minute? Let's go through these again. since I forgot to record, but it's good little practice. Walk me through this one. Which one looks harder, the left-hand side or the right-hand side? Okay, the left. Our most basic trig functions are sine and cosine. Do I have a trig function that is squared and that's being added or subtracted with 1? Yes. I'm going to leave sine squared alone. And I'm going to look on my Pythagorean identities. And 1 plus cotangent squared, what does that equal? Cosecant squared of theta. Now I'm trying to get to 1. You can look at this two ways. You can look at this one of two ways. You can look at sine squared and cosecant squared. You should see this right now and be like, oh, those are reciprocals of each other. Don't just cross them out at this point if you see it. Actually show me the next step. But you can either convert sine to cosecant or cosecant to sine. But I'm going to leave it, since sine is our most basic, I'm going to leave it as sine squared. And then I'm going to multiply that by 1 over sine squared. Do you guys agree with that? Okay, good. And then what happens with my sine squareds? They cancel, and I get 1 equals what? There you go. Good. All right, good. Let's look at this one. Let's go through this one again. I say again, people at home, because I forgot to record the first time I did it. All right, there's a lot going on in this problem. I understand that. I feel like the right-hand side is a little more involved because there's a minus sign rather than just the multiplication on the left. So when I see tangent, I think, oh, tangent is the same as sine over cosine, right? And I see sine squared, that's the most basic one, we're good. So if I look at 16, we're on 16, yes? When I look at 16, I'm like, okay, let me see what I can do here. What are you guys thinking? I'm doing this differently than Miss Carver did. Huh? Let's just do both sides, all right? Let's just say some of you guys are like, I just want to change everything. Okay, fine. Tangent becomes what? Sine squared theta over cosine squared theta, yeah? Then I have sine squared theta over 1. So this becomes what? Sine to the 4th theta over cosine squared theta, correct? Okay. Let's do the right-hand side. What can I do in terms of sines and cosines? Sine squared theta over cosine squared theta. Okay, agreed. Minus what? Sine squared theta over 1. All right. I have two fractions that don't have the same denominator. What do I need to do? Multiply. What am I going to multiply the bottom by? Cosine, right? You guys with me? So I have sine squared theta minus sine squared theta cosine squared theta over cosine squared theta. Yeah? All right. Well, now what? What do you notice that both of these terms have? They both have a sine squared. So I can pull this sine squared out, and I'm left with 1 minus cosine squared theta. We created a Pythagorean identity. We like that. When I created that Pythagorean identity, what does 1 minus cosine squared theta equal? Sine squared theta. So what's sine times sine? Sine to the 4th theta over cosine theta. Am I okay with this answer? Why am I not? I want one side to be the same as the other, correct? But do you guys see how I use both sides as kind of like a guide to get me to that answer? Which would be easier to convert back to for my verification statement? The left-hand side or the right-hand side? The left, because you guys can easily see how you pulled it apart, right? You could now put it back together. You can now say, okay, well, this side is sine squared theta over cosine squared theta times sine squared, right? Which then becomes tangent squared theta times sine squared theta. And then you would do the exact same thing with this side, right? I just want, for your verification statement, I want the left-hand side to equal the right-hand side with something you began with. That should be very easy to do once you go through and see, oh, look, I made them the same. Now I can just go backwards. Does that make sense? Okay. Okay, now we kind of move backwards. Obviously, we start off with the harder ones. Now we're going to come backwards. So let's look here. Which side, guys, looks more difficult? Oh, the left, for sure. Are we adding or subtracting anywhere in here? No, so this should be real simple to do. What's our most basic function? Sine and cosine. So let's just go through and change everything to sines and cosines. What is sine going to become? Tangent going to become? Sine over cosine. Agreed. What's cosecant going to become? 1 over sine. And then I have cosine over 1, right? How else can I smush this together? I have sine x over cosine x times what? Cosine x over sine x. Well, what do you guys notice? Why can those just cancel? Because we're multiplying. So 1 equals 1. All right, you guys, we can do this. Let's focus. Which side looks a tad more complicated? The left. I agree. What do you notice, though, on the left? What do you notice that these are? Same terms, but what? Opposite. They're opposite of each other, right? So what can we do? Think algebraically. FOIL, right? Sine times sine, sine squared. Sine times positive cosine plus sine cosine. Negative cosine times sine is minus sine times cosine. And then negative cosine and positive cosine is minus cosine squared theta. Yeah? Everybody with? Okay, so what happens to the sine cosines in the middle? They cancel out. So you're all left with sine squared theta minus cosine squared theta. How many of you crossed that out and said it was 1? What is the Pythagorean identity? It's got to be plus. Is there anything I can do with this Pythagorean identity? Sine squared plus cosine squared equals 1. That would give me sine minus cosine. Anything? If I subtracted the cosine, then I would have 1 minus cosine equals sine. I like the way you're thinking, though. Can I change this? Can I somehow manipulate sine squared minus cosine squared and make it equal to 1 or negative 1? Well, I know. I like, hold on 1 second. I like the way you're thinking. I can't just make this a 1, but all of you are saying, well, wait, can I change something to, look at where you're trying to go. We're trying to go to where? We're trying to go to what trig function? Cosine. Well, can I do something with this Pythagorean identity that I could replace this with cosine? What could I do? If I move this over here, sine squared becomes the same as what? 1 minus cosine squared theta, right? Minus cosine squared theta. You guys agree? All I did was manipulate this. I moved the sine over. I got 1 minus sine squared equals cosine squared. There's no way I could have gotten sine squared plus cosine squared equal to 1.
You move the cosine over.
Say it again?
You might move the cosine over.
Yes, I'm sorry. I was thinking, I wanted it to be in terms of sine. Yeah. Moving that over to get this. So now I have 1 minus cosine squared theta minus cosine squared theta. 1 minus, if I have 1 minus cosine squared theta and another negative cosine squared theta, how many cosine squared thetas do I have? 2. Which is what we had right here. So a lot of you got to this point right here, and you're like, that's a Pythagorean identity, but just it should be a plus and it's a minus. You can't just plug in -1 because you think it should just become negative. you have to use the other side of your verification to kind of give you an idea, a roadmap of where you're going. When you got here, you're like, okay, this isn't going to equal 1, but I'm trying to get to cosine. So can I do something with that Pythagorean identity that I could replace the sine with a cosine? So again, I know this is confusing. I know this is frustrating sometimes, but you guys just have to try something. Do you understand what I mean by that when I say you have to try something? All right, is there anything up here in the...
I needed 12.
You need 12?
Yeah.
Where's 12? Right here? Okay. I don't have a lot of room, so let me... Okay, this is a factoring problem. How did I look at this and go, oh, it's a factoring problem?
Weird.
There should be a theta here. I have two trig functions, correct?
Yeah.
One of them is squared, one of them is not. All right, we're simplifying this. It's not equal to anything. We're just simplifying it. So I have to think about this in terms of a quadratic. This is in terms of a quadratic. I have sine squared theta minus 2 sine theta plus 1. If you have a problem like this on your quiz, it'll probably tell you in the directions to factor and simplify. I don't know if we're just going to just automatically assume that you're going to look at this and factor it. But if I factor this, what times what, Julian, would give me sine squared theta? Sine times sine. Good. So sine theta, sine theta. What times what gives me a positive 1 when I multiply, but a negative 2 when I add? Minus 1, minus 1. Okay, that's simplified. That's all you could do. You're just pulling it. When you have a quadratic where the trig functions are the same, one's squared, one's not, you're just going to factor it. Anything else? What else? 10? Okay. Oh, right away you guys wanted to go, oh, this equals 1. Why does it kind of look like it equals 1? Now does it equal 1? Yes. Is that what the problem says? No. I would love to give you one that's simple, but we didn't. All right, so here we go. We have a function. This is a good question to do. We have a trig function on top that's squared. We have one on the bottom. Looks like it might be a Pythagorean identity, but I know it's not because why? Because it's not squared. Can I pull the denominator apart? No. If it was 1 minus sine theta over cosine squared, you absolutely could. If it's a monomial, if it's one term, but it's not. It's a binomial. So what did we do? How did we get rid of... Yep, by the what? By the conjugate. Good. You guys with me? Okay, so let's simplify the top. I'm just going to rewrite these together. No reason to... Huh? And then on the bottom, when we FOIL, 1 times 1 is 1. I have a positive sign and a negative sign, so they'll cancel out. And then negative sign and positive sign gives me 1 minus sine squared. What is 1 minus sine squared the same as? Cosine squared. So this crosses out and becomes cosine squared theta. And then what happens? Cosines cancel. So the only thing we have left is 1 plus sine theta. What else? What other ones can I go over? Yep. Sure. Guys, right here. 1 minus cosine squared on number 2. What does that become? 1 minus cosine squared theta is what? Good. Sine squared. What can I do now? Tangent. Good. If I asked you that the first day we did this, you guys would have just still been going, So that's better. We're better. We're better. We're better. We're better. Anything else? What number? Yeah, these top ones are bad. Okay, so I'll upload this. You guys can rewatch it tonight. Again, Miss Carver put all of the alternate ways to simplify and to verify on the practice answers that I posted, so you guys can look at those as well.